Welcome to Homework Lib.
Hi, so over here we want to rank the molecules in order of increasing boiling point, and in order to do that, let's remember that the strength of intermolecular forces is going to be directly proportional to the boiling point. The stronger they are, the higher the boiling point. So over here we just need to identify the intermolecular forces that are going to be present. In the first case, we're going to have only London dispersion. On the second one as well, London dispersion forces. Over here we're going to have a polar bond. Actually, we're going to have several bonds that are going to have certain polarity. And in this case, remember that the nitrogen atom is going to have an extra pair of electrons, which is not going to allow this to have the configuration in which the total dipole is equal to zero. So over here, the intermolecular force that is going to dominate is going to be the dipole-dipole interaction because of these polar bonds that I just mentioned. And finally, we're going to get an NH part over here. So this means that we're going to have hydrogen bonding. Recall that the strength of intermolecular forces is going to be as following. The strongest one is going to be hydrogen bonds. Next up, we're going to have dipole-dipole interactions. And at the very bottom, we're going to have London dispersion forces. So an easy way to identify the presence of each of these types of interactions. For hydrogen bonding, we're going to require the presence of OH group, NH group, or FH group. These are going to be the most common ways in which we're going to find hydrogen bonds available in our structure. For dipole-dipole interactions, we're going to have polar bonds. And London dispersion forces are going to be everything else, essentially everything that is just simple covalent bonds or that are not just covalent bonds. Remember that the London dispersion is going to increase with number of electrons. Regardless, they are going to be the weakest ones, so there's not going to be too much to say about them. But an important fact about this is that the more ramifications, the weakest the interaction, the weakest they become. Why is that? Well, think about, for example, something that looks like this. It can have an interaction with another molecule that is quite similar to that, like this, right? There are going to be a lot of intermolecular interactions between both of the pieces. But what is going to happen if I start adding ramifications to this? Let's say that I add over here a fellow like this, to like this, and a fellow like this. Well, when I want to stack something else, the mere volume of the molecule is not going to allow us to have an effective interaction. So over here, the interactions are going to be only at certain points, since everything else is going to be too far apart due to the steric effect that is going to come here. So with that out of the way, we can continue with the actual question. So to rank these ones in order of increasing boiling point, the one with the highest boiling point would be this one over here. Next up, we're going to have the dipole-dipole interaction, and in between the ones with the London dispersion forces, this one is going to be weaker compared to the one on the left. So there would be 2, 1, 3, 4. And now we're going to rank the molecules in order of increasing strength of molecular forces. So again, over here we're going to have London dispersion. Also here, London dispersion. These are also going to be called sometimes van der Waals forces, but both of them are going to be correct essentially. Over here, we're going to have dipole-dipole interactions because these are going to be clearly polar bonds. As you see, over here, we're going to have a delta minus and a delta plus because of these polar bonds. And finally, due to the presence of this OH group, we're going to be, and also this OH group, we're going to be able to have hydrogen bonds. So the order is going to be the strongest one, hydrogen bonds. The next one would be dipole-dipole interactions. And over here, the weakest one would be the very bulky object that we're going to have there. As you see, we have a lot of ramifications compared to the one on the left. And with that, it would be all. Thank you very much, and have a good one.